Yeah, we will start our webinar. Dear colleagues, dear friends, good morning, good afternoon, and good evening. Thank you so much for joining us today in the webinar on Build Back Wiser, Engineering a Sustainable, Inclusive, and Green Future with Ethic AI. This webinar is organized by the Committee on Engineering for Innovative Technologies, World Federation of Engineering Organization, with namely WFEO. My name is Peng Jing, chair of this committee and also the vice president of China Institute of Water Resources and Hydropower Research. I am a water engineer. So if I have the pleasure to just brief the background of the webinar. Last year on 24th November, the recommendation on the ethics of artificial intelligence was adopted by UNESCO's General Conference, defining the common value and principles which will guide the construction of the necessary legal infrastructure to ensure the healthy development of AI. So on the first World Engineering Day in 2020, WFEO released the Big Data and AI Principles in Engineering to promote responsible conduct of big data and AI innovation and application in engineering. So AI technology actually holds great promise for empowering people and addressing critical global challenges such as climate change, food security, inequality, healthy, and education, etc. However, they can also raise fundamental ethical concerns and deepen existing divides and inequality in the world. So engineering and engineers as one of the key AI actors and practitioners of AI innovation and application should raise awareness of AI ethics, promote the implementation of the recommendation and the principles with responsibility. So, and that's why we are organizing this webinar and to celebrate the World Engineering Day in 2022 this year, and also to discuss the roles and responsibilities of engineers while conducting AI innovations and applications. So please allow me to introduce to you the agenda and our speakers today. As you can see from the share screen, first we will have Mr. Gong to give an opening address on behalf of WFEO. He will also to give a keynote speech on ethics in engineering and engineers' responsibility. After that, Mr. Maksim Karliuk will give the second keynote speech on the UNESCO recommendation on the ethics of AI. Then we had the pleasure to invite Mr. Frits, Bussemaker, take over the floor and preside over a panel discussion with three panelists, Mr. Ali Hessami, Ms. Claire, Vishik, and Ms. Toyosi. Akerele-Ogunsiji. I'm sorry if I did not pronounce the name very correctly. So first, let's welcome Professor Gong, immediate past president of WFEO, to give an opening address. And after that, welcome his keynote speech. Professor Gong, the floor is all yours. Please.
Thank you, Professor Peng. At first, please allow me, on behalf of the World Federation of Engineering Organizations, shortly WFEO, to welcome all of you and to extend sincere thanks to all speakers, to Maksim, to Frits, and to all panelists. It's very important is welcome to all participants to join this very important webinar. We're focusing on artificial intelligence, which is playing a central role in the fourth industrial revolution and the digital transformation. However, I understand this webinar is not focused on the technical side of the artificial AI, but the AI ethics. I think the purpose of AI ethics, the implementation of the principles of AI ethics, is to ensure what we need, the AI, what we need, what we want is the artificial intelligence AI with human values and for sustainable development. So please allow me to talk about engineering ethics and engineers' responsibility generally before our expert from UNESCO to introduce the recommendations of ethics on artificial intelligence. Engineering is to deliver products, tools, and services to solve problems in human life and productivity by applying science, technology, mathematics, design, and management principles under certain conditions, economic, social, cultural, and environmental conditions. However, engineering solutions usually needs to satisfy conflicting requirements. For example, efficiency needs higher technique and costs more money. Safety adds to complexity, and improved performance increases energy consumption and weight. So the engineering solution should be the maximum solution for all these factors. Engineering practice is a complex process with potential risks. For example, environmental risk, such as carbon emission and pollutions, quality and safety risks in engineering projects, during the engineering projects and by its products, social risks, such as interest conflicts and the damage to some groups' interests. Engineers is a professional with great responsibility for public good. Engineers shape the future, and their work affects the lives of millions of people, for better or worse. That raises enormous ethical issues in every engineering fields, from data through biotechnology and energy to environment and aeronautic. Engineers also impact on individual and communal welfare in many direct and indirect ways. It is crucial for engineers to understand the risk and to ensure the safety. Privileges of engineers bring with them important responsibilities. Reversely, their behaviors affect the public confidence and trust in the engineering profession. To this end, engineering ethics is crucial for engineering community. Engineering ethics raise the ethical awareness of engineering community and cultivate their ethical conscious knowledge and skills, such as the ability to recognize the ethical aspects of engineering solutions and to abide by engineering ethical standards so that to fulfill the ethical expectations of the general public, to identify the different and even competing ethical concerns, to analyze the issues that might underline those concerns, and to respond effectively to those concerns. The engineering ethics helps professionals uphold the highest level of ethical conduct and maintain standards of practice and integrity pertaining to their professional duties. The WFEO has released a model code of ethics some 10 years ago, consists of 4 parts: demonstrate integrity, practice competently, exercise leadership, protect the natural and built environment. So that's a model code we released, and now it's under updating. Based on the model code, we also released the model code for of practice for sustainable development and environmental stewardship, which consisting a 1-page listing of 10 principles and another interpretive guide, which is relatively longer. And we have also released a model code for climate change adaptation for engineers a few years ago, which consists of professional judgment, integrating climate information, and practice guidance. That's a relatively long document. Not only WFEO, other engineering organizations such as IEEE, NSPE, ACM, ACME, and many other engineering organizations has these ESO codes. However, today we are facing new ethical challenges and concerns brought mainly by digital technology and bioengineering. They dealing with a privacy violation, intellectual property, technical trust, cybersecurity, ethics dealing with genome editing, digital divide, human and machine relationship, and so on and so forth. And to respond to these new challenges, the WFEO Committee for Engineering Innovative Technologies, led by Professor Peng, has released 7 principles on responsible conduct of big data and AI innovation and application in engineering 2 years ago in the early 2020s. In fact, that was released on the first World Engineering Day, 4th of March, 2020. So the first principle is good for humanity and environment, followed by inclusiveness, fairness, public awareness, and empowerment, opening and sharing while respecting privacy and data integrity, transparency, accountability, peace, safety, and security. Finally, collaboration. A very important understanding of WFEO to the responsible ethical engineering or responsible conductor with big data and artificial intelligence is to maximize the benefits to all users inclusively and environmental friendly, while being aware of risks and taking measures to minimize these risks, as well as to inform to users and stakeholders. So maximum the benefit, minimize the negative impacts. That's what we understand the responsible conduct of engineering. And a very important progress is, as mentioned previously by Professor Peng, is the UNESCO recommendations on the ethics of artificial intelligence. So how to implement these recommendations in engineering practice? So I would like to mention some important points as a proposal. First, to introduce this recommendation in engineering community and transfer this recommendation into engineering ethical codes as well as technical standards. Now we are working on it. Second, to incorporate the recommendation in the engineering education. Third, build partnership with all stakeholders to strengthen the consensus which has been made by UNESCO of its more than 190 member states, and to monitor the implementation of the recommendation. And promote AI innovation, technical innovation, to break through the technical bottlenecks such as inexplicability and reliability, etc., and to increase the transparency and affordability of AI system, AI applications, and to develop effective technical tools for privacy protection, such as privacy computing and bias detection, which should be provided to the users, not only provided to the developers. So we can mention much more. With this, I conclude my talk with the mentioning of the theme of this year's World Engineering Day for Sustainable Development, that is build back wiser engineering the future. I think the key word is wiser. That means better leveraging science and technology responsibly and ethically for accelerating the delivery on the SDGs. Thank you so much. I stop here.
Thank you, Professor Gong. Thank you so much for the opening address on behalf of WFEO. So would you like to continue your keynote?
I have already did it.
Oh, that's all the keynote. Oh, I'm sorry. Yeah, thank you so much for just briefing the principles and 7 principles and how we build back wiser in engineering community. Thank you so much. So next one, we will welcome the second keynote speech given by Ms. Gabriela Ramos. Gabriela is the Assistant Director General for the Social and Human Science of UNESCO. She will talk on the UNESCO recommendation on the ethics of AI. Gabriela, the floor is for you. Thank you.
Very much. I'm sorry, but Gabriela Ramos, unfortunately, we couldn't make it today, so I'm stepping in here. So my name is Maksim Karliuk, and I'm working in the social human sciences sector, and work specifically on the recommendation on the ethics of artificial intelligence. From the very beginning, from its inception to its adoption, and now on the implementation. So I would like to start by saying, if I may also ask to share the slides, and I would like to start by saying thank you very much to Mr. Gong for the presentation. I really learned a lot from that, and really amazing initiative that you have there, and the way you are seeing how to implement the recommendation and try to integrate its provision in your work. That's really amazing, and I really hope that we together we can make this happen indeed. So indeed, it's a great pleasure to be here with you at this very important event to celebrate the World Engineering Day for Sustainable Development. And I will just quickly start with, we can go to the next slide, that as we know, all of us know, AI has immense potential to improve the lives of people. It can provide new solutions to concrete problems that we face. Examples are really multiple. For example, AI is being used to optimize food production while minimizing waste, altogether contributing to a more efficient and sustainable food ecosystem. It is also being used to predict disaster risks, monitor pollution levels, to support the use of more sustainable energy sources. And with the pandemic, we saw that AI has demonstrated the possibilities in predicting infectious diseases or tracking their spreads and accelerating the development of vaccines. And AI can also evidently support the remote working and learning, which opens up a number of opportunities for the pursuit of education.
Maxim, yep. Maxim, I apologize to interrupt. Could you maybe put your microphone a little bit closer to your mouth?
Okay.
Because then we can hear you a little bit better. Thank you. Sorry for apologize for the interruption. We want to follow you. Thank you.
Let me know if this is any better, or should I speak up maybe?
If you could speak up a little bit, I see some reactions in the post which will help. But thank you so much.
All right. Sorry about that. So I will try.
No worries.
So having said that, and if we move to the next slide, not everyone has reaped the benefits of the rapid digitalization. Much of AI technology, and this is just some of the examples, again, examples are also multiple. Much of AI technology is currently concentrated in the hands of a few companies in a really limited number of countries. Women, and particularly those from developing countries, are once again being left behind. We know that AI has the potential to reproduce biases and discriminatory practices. And the most recent estimates say that it will take more than 135 years to close the gender gap worldwide. And the largest gender gap, in fact, is in AI and data, where women make up 32%. So another thing is the governance of data is sort of another area of concern. And the current pandemic has seen an explosion of AI-powered applications for monitoring and contact tracing. At the same time, this has implications for privacy and data protection. And in some cases, there are no precautions against the potential use of the personal and sensitive data collected for purposes beyond pandemic control, for instance, for mass surveillance of the population. And there are also present environmental concerns, which have been already mentioned, simply because major AI methods currently employed are based on processing of ever-increasing amounts of data and computing power, which leads to increasing energy consumptions and consequential impact on carbon emission, but also depletion of resources altogether and deterioration of the environment. So, for example, data extraction itself consumes nearly 10% of energy globally, and there is an estimate that training one large deep learning model produces about 300,000 kilograms of CO2. And someone calculated this roughly around 125 round-trip flights from New York to Beijing. So at the same time, it's true that algorithms are becoming more efficient. There is indeed considerable success in reducing the amount of compute needed to train a neural network. But at the same time, from 2012, the data that I have from 2012 to 2018, the computational power required for deep learning has increased 300,000%. So it's not sustainable in the long run. So the important point I would like to make before it's kind of transition to the recommendation itself, and the thing I would like you to take away from my presentation, one of the things in particular, is the following: AI technologies are not value neutral. You can often hear that AI is just a tool used by people, and you can use it or bad way in good or bad ways, but this is not really the case. So among others, AI systems are biased due to the data on which they are trained. So AI systems depend on what kind of data is used, and data can be incomplete. It can include societal biases or stereotypes, which can have really far-reaching consequences. It can include societal biases. Well, I mean, I mentioned it already, but for example, lack of gender representation in the data used to train AI algorithms is a really major issue, and gender biases are often present in AI data sets, and algorithms produced based on such biased data have the potential of spreading and reinforcing harmful gender stereotypes, which is, of course, the risk of further stigmatizing and marginalizing women on the global stage. Moreover, teams who develop algorithms can translate their own values into them. For example, the absolute majority of such teams are male only, which has its own consequences with their biases and tastes. And systems, in a wide sense of the word, tend to reflect the people and their values who design them. And people are still making choices every step along the way for AI's development. So their personal ideas and the ideology of their group are what's being passed down through the AI ecosystem. So to put it simply, if you or someone whose language, gender, race, religion, politics, I don't know, culture, or your own are not in the group, you can pretty much bet that whoever gets built won't expect who. And beyond that, the AI system can learn from the information from outside world and in ways that their creators could not have predicted. And such systems can operate independently from the creators who operate. That will complicate the task of determining who is responsible in the end when something happens. So these trends are quite risky because they open the door for higher levels of discrimination. And digital technologies are not only producing the most innovative products, but they are also doing it at a really fast pace and are changing the way many other sectors operate as well. What is clear is that we are at a crossroads for digital technologies, and we must ensure that they contribute to the good of humanity and the achievement of the sustainable development goals, and that they do not infringe upon human rights, freedoms, or well-being. And there is much to be done, of course, and that is why recently the main priority of UNESCO has been the recommendation on the ethics of artificial intelligence. And after many months of constructive dialogue and negotiation, our 193 member states adopted this first standard setting instrument in this field. And it constitutes an ambitious, very ambitious and wide-ranging new template for the ethical development and deployment of AI. Next slide. Yeah, so this is the adoption. And in the next slide, the recommendation is composed of a set of human rights-based values, principles, and policy areas. Let's move to the next slide. And all of those, they operate together for putting people and their individual rights as well as environmental concerns at their center. Can we move to the next slide, please? I would like to specifically highlight, I mean, I cannot obviously go through all of the values and principles here. I would like to highlight the one principle which I believe is quite innovative and specifically relevant for engineers. And this one is the principle of proportionality. So the principle of proportionality is a set of conditions that must be satisfied to justify the usage of this or that AI method. This can be further expanded to justifying using AI systems as such for a particular purpose. And the essential idea here is that use of AI should fit the pursued aims and should not exceed what is necessary to achieve them. And this will require striking a balance between the means used and intended aim. And these considerations are particularly important in the case of use of data-intensive or resource-intensive AI methods because of their impact on such concerns as I mentioned, the ones on environment, on bias, on privacy, etc. So, for example, it is generally true that a machine learning algorithm based on data is all the more accurate and relevant that data is precise and extensive, which can also reduce bias. At the same time, at a certain point, they come into conflict with personal data protection. In this case, there is a clear conflict between using larger data sets to offset AI biases, and versus privacy. In certain scenarios, we can turn to AI methods which use, for example, less to no personal data or computational resources. And the possibility of a choice relies on the fact that beyond the currently dominant methods, there are other ones, such as reinforcement without data in a simulated environment, one-shot learning, and some others. So in fact, there is research that shows that in certain contexts, simple, explainable algorithms often have close to the same prediction power as black box methods like deep learning. And in such scenarios, the added benefit of the black box techniques is not worth the big cost of, for example, of interpretability. So this is just one example, but here I would like to turn to the next slide and say that critically, what is critically important is that recommendation goes beyond the declaration of ethical values and principles to include concrete policy actions to operationalize these principles and values. This is crucial because often bias and discrimination manifested downstream as experienced by users is a product of structural inequalities and exclusion upstream, such as the lack of diversity in the management or technical teams that develop these AI tools. And with the recommendation, we're looking at very specific ways how to operationalize principles such as transparency, accountability, and responsibility. For example, the recommendation provides very strong policy actions on the management of data, of privacy, and access to information, and assesses rules for keeping control over the data in the hands of users, allowing them to access and delete information as needed. It also calls on member states to ensure that appropriate safeguards for the processing of sensitive data and effective accountability schemes that should be in place, and redress mechanisms should be provided in the event of crime. On another policy area, we are wary of the terrible impact that technologies are having on children, on democracies, on misinformation, which can divide our societies. And that's why the recommendation takes a very strong stance on several issues, such as AI systems should not be used for social scoring or mass surveillance purposes. Particular attention should be paid to the psychological and cognitive impact that these systems can have on children and young people. Member states should also invest and promote digital media and information literacy to strengthen critical thinking and competence. So another focus is also gender, and gender equality is one of the priorities of UNESCO. And I'm proud to say that recommendation showcases a very strong chapter on to advance gender equality in the digital and AI world, and it recommends adopting very concrete measures to promote gender parity in this field. Very importantly, it also talks about women not only as users, but also shapers of this technology. If we go to the next slide, the recommendation provides for very concrete mechanisms to implement the recommendation. And there are two particular innovative tools we are currently developing. The first one is the Ethical Impact Assessment, or EIA, which aims to help member states and other stakeholders to evaluate the benefits and risks of AI systems, to put in place risk prevention, mitigation, and monitoring measures. It also helps to deploy redress mechanisms for those who have been adversely affected by this technology. The other tool is the readiness assessment methodology, which aims to assist member states to identify their readiness status related to the recommendation, recognizing that different member states in different parts of the world are different stages of readiness with the respect of their technological development level and respectively the level of capacities to implement the recommendation. And that's why we are here also to help the states to advance. Here I would like to quickly mention also specific focus areas that I think probably for engineers to consider while working on the goal of achieving SDGs. And this could include identifying and experimenting with AI technologies relevant to SDGs, such as analyzing data for development, I would say data for development in general, relevant to the agriculture and medical diagnosis. Geographic information system needed in public service planning are also important in this respect. Also systems for disaster prevention, for emergency planning and disease monitoring. Other examples are control systems used in naturalizing intelligent cities through energy and traffic control and management of urban agriculture. And also applications that promote human empathy, focused on diminishing violence and exclusion and increasing well-being. So this is just a few examples which to keep in mind. I would probably stop, and I would just finish up by saying that we should aim at promoting the potential role of AI technologies in sustainable development by collaboration between national and international institutions and NGOs in technology sectors. And the recommendation on the ethics of AI is a great framework for that. We, as UNESCO, stand ready to support our member states and other actors through various tools that I mentioned, and those that I haven't mentioned because there are others. And to close, history is replete with the examples of humanity coming together to address critically important issues. And I believe that this will be another, say, shining example, hopefully shining example of what we can accomplish with shared vision and coordinated action together. So on the last slide, you see where you can at the work we are currently, at the recommendation itself and the work we
Thank you. Thank you. Thank you so much, Mr. Maksim Karliuk, for your very wonderful introduction of the UNESCO recommendation on the ethics of AI. I'm sorry I just missed the name of the keynote speaker. I think your keynotes is very, very informative, and you present the framework, the values, and also the principles of the recommendation. The recommendation do provide a concrete and actionable pathway to translate the values and principles into policy. Very, very excellent presentation. So far, we had two enlightening keynote presentations already. Next, we are going to have a panel discussion. For this part, Let me gladly hand it over to Mr. Frits Bussemaker. Frits is the chairman of the Institute for Accountability in the Digital Age, an association set up at the instigation of UNESCO. He is also a member of the Big Data and AI Working Group under the Committee on Engineering for Innovative Technologies. So please, Frits, the floor is yours.
Yes, thank you so much for the introduction. And also, I'd like to point out I'm an engineer by education as well. So I'm very pleased to have this discussion because in 1982, when I started my education as an engineer at Delft University, in all those years I was there, I never once had a discussion on ethics. We were building things. We were not thinking about what it could do. So the fact that today we have this discussion, I'm very honored. And we're going to take on that discussion on AI and ethics specifically, and we have well over an hour to do that. That also means to the audience, you have an opportunity to actively participate. So please put in your comments, your questions in the Q&A. We'll look at that, and as soon as you have something, we will add you to the discussion because also your insights are meaningful. But however, we will start with a panel discussion, and we have 3 distinguished guests for our panel. And I'd like to, let's see, so Toyosi, I see you have the camera on, Claire and Ali. Please also put your mics on. So we have Ali Hessami, the chair and technical editor of IEEE, of the 7000 standard, which we'll extensively discuss later. Claire Vishik, a Intel fellow and a leader in emerging technology and policy, and Toyosi Akerele-Ogunsiji, a social entrepreneur in data science and artificial intelligence education. So panel members, a warm welcome to this discussion. And I also would like the opportunity, as Gong and Maksim, you're still here, that if needed, I'm going to add you as extra panel members because maybe the audience will also have a question for you as well. So if you're okay with that, we might come to you. But first, panel members, welcome. And maybe a very first question before we deep dive into this is, I'd like to each ask all the panel members, if you have an opening statement, but more importantly, what's your first reaction based on the 2 previous presentations? And Ali, may I start with you? Welcome to the panel. And what's your first thoughts?
Thank you, Frits. I think what it tends to reflect is probably modern recognition, sudden recognition that ethics is as important as anything else we as engineers have been doing. Unfortunately, we haven't been warned about it, we haven't been trained about it, we haven't engaged in it, and we haven't even engineered it in our products and solutions. To me, it's a great missed opportunity for humanity to have had this awareness and knowledge, including myself, like you were highlighting. I never came across engineering ethics throughout my higher education phase. And if I may say so, in a briefer statement, I'm forever grateful to AI to knock us into shape and into sense and say, your ethics is important. Now that I'm going to take your agency away from you, take heed, start paying attention. It's as important as safety, security, sustainability, and just about any other ET that you add to the end of a quality of a product.
Great. Well, good you're on board. I'm going to move on to Claire. Welcome. And first thoughts as a fellow of Intel. Does Intel inside mean ethics inside?
Of course. But let me maybe share a few additional thoughts that describe this area. I think that ethics have always been important to engineers, and this is especially true in the technology area. It's impossible to underestimate the role of technology today. After all, technology enables this panel. It allows us to join virtually from several continents. And in joining this panel, we have overcome a number of concerns, ethical and societal, that have been associated with even this type of technology, video conferencing. I am talking about privacy, I am talking about data protection, I am talking about data security, but also, well, transparency, equity, and many more. So, although we may not have had specific training for engineers, I would like to posit that ethics has always been important to engineers, and it's especially true in the technology area. When technology has such broad applicability, the questions of ethics inevitably arise, and they arise in numerous contexts, not just artificial intelligence. So with regard to artificial intelligence, in fact, ethics discussion predated the appearance of the technology. The technology itself appeared, well, maybe in the 1960s, but the discussions of ethics, the main question, what do we do when, as the previous speaker so well said, we lose our agency to computers? What happens if computers are in opposition rather than in collaboration to humans? That has been a concern from the earliest pre-computing era when powerful counting machines appeared, and it became evident that there are some things that computers can do much better than humans, for instance, computation. So while the discussion of ethics has become considerably more active recently, it certainly has not been non-existent before. And in fact, some of the ethical characteristics of artificial intelligence that we admire and require today, such as explainability, for example, they draw from this earlier era of rules-based systems. In rules-based systems, of course, explainability is a given because you define the system step by step. You can very easily explain how a decision was made. You can very easily see how the computer arrived at the conclusion. But in machine learning based automated systems, this explainability part is not very easy to achieve because a lot of code is generated automatically. So a lot of ethical positions we have hark to the era of the earlier systems. And one of the duties of the engineers in the near future, I think, will be to reconcile this picture that we inherited from the rules-based systems to the new semi-automatically generated artificial intelligence.
Okay, Claire, thank you so much for your insights. And I will give you indeed, ethics has always been at the table, although if I might rephrase your statement, it has always been implicit, but it's now become explicit. Okay.
Yeah,
hey,
thank you.
I'm going to move to Toyosi. You are a social entrepreneur in data science, artificial intelligence education. Does this, well, welcome, first of all, and how does this resonate with what you're doing in your daily life?
Thank you very much, Frits. It's such an honor to be here. I thought the keynote speaker was extremely brilliant in the examples and the points that were made, and I'm hoping that more, folks from Africa are able to sort of like join this conversation, because this, I think, we are, sort of like at the receiving end of all of the overload of information, around the subject matter of AI and other related concepts like, machine learning, data science, analytics, and all that. But to your question, I think the first thing we need to look at is, the applications of AI and its dimensions, ethical dimensions, within the grand context of engineering, if you like. I think, first off, it's important to look at it as artificial intelligence is more of a problem solver than the problem itself. I think the major challenge that we've seen around the conversations we're having in Africa at the moment is, especially Nigeria, where I come from, my work, is there's a lot of pushback from, around the system, from citizens who don't quite understand that, the various opportunities that AI does present in terms of helping us simplify our systems, improving efficiency, for businesses. And I think that boils down, in itself to the foresight that is sort of applied in our policy making processes. I think that it's very important for to begin to leverage, inclusive conversations and collaborative research, from the private sector, from the public sector, in the social sector, to begin to have these conversations around the possibilities of artificial intelligence, the opportunity it does provide in terms of even, creating more jobs, simplifying systems, improving and enhancing the efficiency capacity of businesses and organizations. But as we have the conversation around ethical AI, I think it boils down a lot more to, inclusivity. How do we ensure that artificial intelligence does not leave anybody behind and does not deprive them of the opportunities? And I think that boils down itself to the quality of education, the quality of the training, and the quality of the instructional content that is giving out, to engineers or to people from various industries. So, for example, at Rise Networks, a lot of our programs, we try to make sure that we utilize a very balanced approach in our training programs, in teaching concepts around AI. So rather than take a financial analyst or an accountant or a medical doctor and say, learn AI because it's important to know it, we're teaching them to learn AI and show, to be able to learn it and master it, to demonstrate how better they're able to serve their communities and, the systems in which we work. So work that is supposed to take, perhaps take, say maybe a day or two to get done, can be done within a couple of hours, because you have systems where a medical doctor now understands how the concept of machine learning, how equipment, is able to fast track and improve his own application of his medical knowledge. And I think that's what we need to do more, in terms of exploring those varying dimensions of artificial intelligence and how ethics, play a very key role in this. How do we upskill people and give them access to equal opportunities using the knowledge of the fact that machines, are not going to replace humans at any point. You still need human beings to train these machines to, be sort of like more effective and more useful, more efficient, more relevant to, human systems that are originally developed by humans. I think that if we look at, the ethics of AI from that angle of how it has the propensity to drive inclusivity and more diversity, I think it's also important to see the role that women will play within the, grand artificial intelligence space, because you have the artificial intelligence space at the moment is still very dominated by men. And if you really want a system that is, you know, that is very balanced, that eliminates all sorts of biases. I mean, this is the International Women's Month, and the theme is around breaking the bias. So how do you begin to take the access of artificial intelligence and democratize it well enough to deliver it to an audience in a way that, you know, sort of doesn't compromise the ethics of the profession? I think for us and for everyone, we will be able to make the best, you know, the best of it.
Okay. Toyosi, thank you for your opening statements. There's a lot of thought in that answer and the angles I can explore. It does trigger me to actually go back to Maksim. And Maksim, I want to link what Toyosi just said to one of the, piece of knowledge on your slide. You said that AI, if I remember correctly, is better at recognizing white men than black women. That's a statement. Now, we were going for inclusivity. We want actually it to be equal. But is the result that it's currently unequal? Is that the result of a bias because it's developed by white men, so they build something for themselves? I am extremely black and white here, I realize that. Or does the currently available technology make that question easier to solve? So a white man is an easier question from an engineering perspective than a white woman. So how can you distinguish between the design and the difficulty of the engineering question in this case? Is that discussed? Is that thought of?
Yeah, thanks for the question. I mean, I don't have a solution for you here, but indeed, I would say it's both. So it's both because of who is developing the system, let's say, and second, the use. As I said, I mean, most of the currently dominant AI methods are based on large amounts of data, and data itself is already. I mean, sometimes it's easier to collect certain types of data. In this specific case, it's easier to collect, let's say, data of white male. I mean, pictures, let's say, of white male than of black female, for example, is one thing. Second thing is that there are already certain societal biases already in this large data sets. And third, the question is who is choosing this data. That also influences. So basically, you see, is that it's on all fronts. The issue is on all fronts, and that's why it should be addressed on all fronts. And that's why, for example, in the, so for example, it's specifically what we consciously did in the recommendation. But when we're talking about ethics of AI in development, deployment, etc., of AI systems, we're talking about the whole life cycle of AI systems. And the life cycle is not, we mentioned specific stages of this life cycle, starting from research and going up to termination of AI systems, because there are also ethical concerns on that side. And there are several stages in between, and we are not even enumerating all of them, because I mean, sometimes it's hard to identify all of them. But that's an important part. We should be always looking at all of those stages. And that's why when I was talking about the ethical impact assessment, for example, the specific tool provided in the recommendation, what we're trying to do there is make sure that this ethical impact assessment tool helps to identify these issues on all stages, at all stages of the system life cycle.
Okay, Maksim, thank you for your reply. And I think it's good to be aware for those engineers listening to this that although the headline could assume just a simple cause, understanding the dynamics and the complexity is something this helps with. Now, I'm going to go back to you, Ali, because as mentioned in the introduction, you are the chair and technical editor of the IEEE 7000 standard. Could you maybe take us a little bit on what that is and how that would help an engineer?
Thank you, Frits. If I may give a quick background to IEEE's initiatives relevant to our discussion today. the Standard Association, part of IEEE, decided to embark on a global initiative for ethics of autonomous intelligence systems, or AIS. That's IEEE's version of AI, basically. Back in 2015, for quite a while ago, in terms of modern tendency or today's tendency to emphasize the ethics of AI. There were a couple of strands to the initiative. One was developing ethically aligned design treaties. That was published a couple of years ago, and that's available as Creative Commons and accessible to everyone. That's the work of few thousand global engineers to put the fundamental principles of human rights, data agency, and technical dependability together as a massive piece of work. There were two other dimensions to the global initiative. One was developing a whole series of AI ethics related standards, anything to do with the process, to do with the ethics of data governance and facial recognition, and that kind of dimension. All of those, I had the privilege of joining some of those initiatives and eventually ended up being the chair of the core standard called IEEE 7000. That was published last September. And the 7000 is the principal process, first global engineering ethics standards published by a global standard development organization. And interestingly, last week I was advised that ISO and IEC have adopted IEEE 7000 as a global standard, and they would be publishing it as an, if you like, rebadged and rebranded ISO global standard for technology ethics. The fundamentals of the standard is that ethics needs to be built into the product and service as far as design initiatives and activities are concerned. It starts, unfortunately, the standard doesn't cover the full life cycle, and I'll explain why, because that's how it was defined in terms of scope at the start. And when I took over, I realized that much of the standards teachings and processes were largely Western oriented. So I have insisted that it has a global dimension, and I'll quickly explain that as well. The standard is built around 5 major processes. One is to explore the context and scope of an application in its environment, because we know ethics technically, at least from a technical perspective, is highly context sensitive. So we start defining our stakeholders, identifying who they are, and describing the concept of operating a product or system in one or many application contexts. The second process largely starts exploring with those key stakeholders what are the values they see either fostered or threatened by that technology or by that method of application, whatever it is. So we don't start with a predetermined list of worry about privacy or make sure accountability is included. We actually elicit all those values from the stakeholders, not just the end users, pressure groups, you name it, designers even, and the executives of the establishment who are developing. The third stage is to take those values and convert them into system design requirements. We call them ethical value requirements. So there is a process defining how you actually convert all those soft values that you've elicited from your key stakeholders, convert them into ethical value requirements, put them in the requirements bucket, if you like, alongside everything else that we system engineers are used to, such as safety and security and sustainability and quality, resilience, etc. And do a bit of, if you like, comparative positioning and horse trading to see what combination of these requirements are acceptable ultimately. And finally, it provides guidance on what we call ethically aligned design, how you take those ethical value requirements alongside all the other requirements of the system and build them into this product or service and validate it. Originally, we had intended to go into deployment and the final phases in terms of upgrade and maintenance and decommissioning of AI products. But we were reminded that the scope of the standard as originally defined in 2016 didn't allow for that. We had to stop at design. So there is a plan to continue with that at a later stage. The final process is a transparency process that amongst all these activities, the 4 key focal points or processes, we need to exercise all the measures that ensure transparency in terms of communication and recognition of who needs to know what at what stage in terms of product or system or service development. The final point I was going to make quickly was the original draft of the standard developed by a colleague of mine who was the vice chair of the standard, Professor Spiekerman, spoke about Aristotle's school of virtue ethics. It talked about John Stuart Mill's utilitarianist ethics, and also about Immanuel Kant's deontological duty ethics. And those all smacked of huge Western influence. And because I was keen that this standard has global outreach and global acceptability, we added a 4th leg to this, if you like, philosophical canons, and allowed any other ethnic, local, historic, or cultural value system to also be used to identify values under threat or being fostered by a product, so that our ethical value qualities that we define are as comprehensive and as regionally adaptive as possible. That standard is now published. Believe it or not, that standard took 5 years to produce. That also shows the challenge of not having a universal ethics anywhere. Everyone sees it from their own perspective, value, cultural, historical, and geographic perspectives. And to arrive at consensus was a major, major challenge, fortunately done. And as I have just announced, it's now going to go beyond being an IEEE standard to become an ISO IEC technical ethics standard.
Hey, thank you so much, Ali. And I assume if we just Google IEEE 7000, we will find that standard. So anybody out there who's interested can find it and apply it.
You can find it, but it's not available in a complementary manner. You might have to deal with that aspect directly with IEEE.
Okay, thank you so much. By the way, in the meantime, I see there are no questions to date or comments made by the attendees. So again, if you have a comment or a question, please put that in the Q&A and we'll pick that up. Claire, I'm going to move to you now. Could you be a client of the standards which Ali just mentioned? And I'll come back to Toyosi as well. Or how do you do that within your organization? Is that, or do you leave them alone, or do you say, hey, that's actually good input?
Intel and industry in general have been the moving force behind the international standards. Intel has participated in the creation of those international standards in a variety of organizations. We do a lot of work in IEEE, although not directly on the standard that was mentioned. We do a lot of work in ISO-IC, JTC1, where a whole committee, SC42, is dedicated to artificial intelligence and is now looking at pre-technical issues, which includes ethics, trustworthiness, risk management, and positions of this nature. a lot of countries, as you know, participate in ISO/IEC, and there is outstanding participation from industry and other organizations in SC27. Like other companies, Intel is also participating in various activities that are set to make sense of various aspects of artificial intelligence. For instance, we have been active in OECD work on artificial intelligence. We have supported NIST in the US. We have worked in ETSI and in member states, as well as Japan, India, and many other countries on the local best practices, guidelines, and technology activities associated with artificial intelligence. So, well, generally, the answer to this question, we are, of course, interested in standards being adopted. We are interested in the technical standards, the next generation, the ones that will create APIs, blueprints for data as it is used in artificial intelligence systems that will embrace the whole spectrum of artificial intelligence. I think this is a very important problem in artificial intelligence that has not yet been looked at carefully. We have looked at artificial intelligence systems predominantly that are human-facing, that have direct impact on humans. But the majority of artificial intelligence systems are not human-facing. They are typically machine-to-machine. I am talking about systems such as focusing on network orchestration, looking at terrain characteristics for autonomous driving, collecting data and analyzing data from data sensors, looking at imperfections or defects on the factory floor, and so on. So this data that they process is not personal data. This data is typically fed to another machine, not to a human. The ethical issues, however, are similar because the outcome is ultimately important to humans, although indirectly. We need to come up with a set of characteristics, perhaps even principles for what is necessary to make non-human facing that use artificial intelligence trustworthy. And one of the areas that were mentioned when you asked the question about diversity of data, is it a difficult technical problem or is it a difficult problem that is entirely ethical? This applies to non-human facing systems as well. Your algorithm for recognition typically is as good as your data. There are many situations where the data are homogeneous. It could have to do with the intent of the system. If the system that we are building is meant to be used in Japan, for example, and it is having to do with facial recognition, then it's perfectly fine that it is homogeneous and that 99% of information there comes from the local population. Similarly, if you are preparing a system for autonomous driving and you only have information about the mountainous terrains, but not about flat terrains, because this is what you have in a certain country, it is probably appropriate. However, there are many situations where this lack of heterogeneity in data creates significant bias. And there are many technical ways today to deal with this. Synthetic data is one of them. Good synthetic data allows you to simulate heterogeneity and create better recognition in situations where you don't have sufficient heterogeneous characteristics in the data set itself. So
Okay.
I think maybe the next generation of questions for us is, can we move from human-facing only principles to ethical principles to embrace the whole spectrum of AI, human-facing and non-human-facing?
Claire, that is a seminar on its own, I can tell you. But also what I pick up from your answer, because Intel is so big, you not only apply the standards, you're so big, you can actually help develop those standards. So it is, to an extent, practice what you preach. But also want to then move to Toyosi again. So, hey, Toyosi, you just heard a couple of organizations present standards, guidelines, available to develop ethical AI solutions. The engineers in your environment, where do you point these people to? How, as an engineer, what am I going to use on a daily basis? How does that work?
Frits, sorry, can you take the question again? I lost you for a moment.
Okay, no, that's fine. Now, we just heard Ali present the IEEE standards. We also heard that Claire mentioned that Intel not only has its own standards, but actually is helping develop those global standards. So I would say those organizations are well catered. Where do you see, when you're busy with social engineering, with startups, where do you point people to? Which are the standards? So are they a derived set of pragmatic standards? Can you directly go to what the WFEO did, or what Ali presented with IEEE? So what do you use or recommend to use in a daily life?
So one of the things that we must understand is that realms like artificial intelligence are still extremely new and nascent, within the African and the Nigerian context. And some of the challenges that we faced in recent times is the availability of, a wide range of data, data sets that can be analyzed to be able to make the right judgment calls or drive the right decisions, within different systems, whether they're public organizations or private, sector organizations. You've seen the movie Coded Bias, for example, and you saw how a Ghanaian researcher in MIT was complaining so much about the facial recognition challenges that she had faced while researching. You heard the story of Timini Gabriel of Google, who was like an AI, researcher, who, had claimed that she wasn't given the room to sort of explore, the opportunities that, she could apply herself, to in terms of researching AI. We still suffer a dearth of, lack of data in Nigeria and Africa at the moment. So in terms of standardization, those are some of the work that, Rise Networks and other organizations like Data Science Africa and a couple of other, artificial intelligence research institutes have been working on to sort of say, what would we consider to be the appropriate standards in terms of standardization, quality assurance, ethical, applications to, using AI within systems. So you also want to be careful not to put engineering and technology in the hands of people who are not naturally, committed to this communitarian issues, if you like. So there, in Africa, in Nigeria, there are already a lot of issues around, social bias, cultural biases, gender biases. I mean, you probably know, you were listening to our parliament just 2 weeks ago. I was on one of the biggest national television last week to speak about the, breaking the bias and the International Women's Day, where I was asked to analyze, how the National Assembly of Nigeria practically voted out, every single gender-related bill, that could, give opportunity for women participation and include women in policymaking. So you naturally already have those underlying cultural, social-cultural biases in our country and our continent. And the big challenge for companies like ours at Rise Networks and a lot of other African countries, companies would be, how do we leverage existing standards from other systems? What can we learn from other systems? I mean, I've taken a lot of learning from Claire and the other speakers today, but how do we take that learning and localize them and then utilize them, recreate them, adopt, before we then adopt them into our own systems? And that's why it's very commendable what the WFEO has done with this event, to put the voice of not just all the other continents on the table, but give Africa an opportunity for participation, to learn from a platform like this, and then take back the knowledge from here and see how we can localize and apply them to our own systems to sort of improve that standardization.
Yeah. So Toyosi, you just reminded me, de facto everybody talking today, watching today, we are a pop-up community. We are now coming together and you're hearing various perspectives. So I also would like to invite everybody to indeed share that knowledge, just connect the people. So Toyosi, Claire, I don't know if you've already done that, but just, I would say, grab that knowledge and make it your own. Now I have a question. I don't know if anybody's able to answer that, but are there already examples where the standards, ethical standards, have made a difference? Are there examples where it's been applied? As an engineer, I want to be very pragmatic. I just want to see how it works and copy that. So, Ali, I realized that
Toyosi has her hand up. Let her speak first.
Yeah, sure. Yeah. Okay, good. Yeah.
Yeah. So one of the areas where AI is really making a difference in Africa is in agriculture. You already know the food security challenges that Africa does have, and there's a new app that was just released in Kenya. It's called Nuru. And it's basically an application, an AI-enabled tool that sort of helps local farmers, literate or illiterate, to utilize basic artificial intelligence measures on that app to check for crop disease, to use predictive analytics to see how the rains affect their crops and all of that. And it works with or without the internet. And so if you think about
Toyosi, thank you. That's a great example where AI is being applied. Could you also comment on how the ethical standards we're discussing today has helped? Did it help create a better AI or not?
I mean, definitely. It took Nuru quite a number of months to sort of commission surveys on, commission surveys and get people to go around the country to say, what do you think works? What would you consider bias? What would you consider to be inclusive, sufficiently inclusive enough? Especially because in this context, you were targeting local farmers who were not extremely literate or lettered. In creating solutions for people, especially if it's artificial intelligence enabled, I think it's important to engage them so that you are not creating solutions for people that do not reflect their interests or their needs, especially if they're at the bottom of the pyramid category of people. I don't know if you're...
Great. Good example. Thank you there. Claire, you raised your hand. So by all means, please contribute.
Yes, Intel is probably an example of what the companies do in general with regard to making use of, they are not so much standards guidelines that in principles that describe ethical approaches to AI. For instance, we have a responsible AI internal framework that makes use of those principles from various sources, and they are applied to evaluate all artificial intelligence projects that Intel is envisaging or in which we are engaging. It looks at the requirements that have become principles: explainability, transparency, privacy, lack of bias, diversity of development teams, and so on, and applies them to every project. In addition, we have an ethical AI engineering team. This team provides consulting at the technical level to everyone who builds artificial intelligence systems who are human-facing and non-human facing, just to evaluate them. These are engineers who understand and help develop those principles, and they work together with the product development, solution development groups. Intel is probably a little bit in the forefront of this work, but I know that other companies have applied similar processes and are making immediate use of principles of ethical artificial intelligence.
Okay, when you see those engineers, they transfer their knowledge, their insights to Intel. Would they also be open to do the same if, for instance, IEEE or UNESCO or the World Federation of Engineering Organization would come and say, hey, could you also help us transfer that knowledge?
Intel is participating in a number of multi-stakeholder dialogues. I mentioned OECD. We are also participating in the United Nations. We are participating in many local and regional organizations and developing technical and sense-making consultative standards as well. So if UNESCO, where I don't think we are participating simply because we were not invited and we're not aware of the opportunities in this effort, needs participation from additional technologists who understand ethics, we are always ready to help.
Well, Maksim, grab the opportunity if you see one.
Yes, thanks for readiness and
okay, thank you. Ali, I want to come back to you. Before we had to prepare this, you gave a fascinating insight on what's happening in the city of Vienna and how you got involved. Maybe would you be willing to share that example? Because it showcases why we're doing this.
Thank you, Frits. I did mention the so-called IEEE's Global Initiative for Ethics of AI, dating back to about 7 years ago as a commencement. The component that I didn't cover in my earlier explanation, which has got an applied case, is ethics certification criteria. All the characteristics that Toyosi and Claire and indeed Professor Gong have mentioned are covered by IEEE's ethics certification. This was driven by some urgency, as well as the fact that most people suffice to issuing principles, and these principles for engineers are very tough to implement, to interpret, to convert into what do I do with this principle, or principle of privacy. How do I build privacy or respect for accountability into my product? And how do I demonstrate? Some, believe it or not, European governments approached IEEE and demanded exactly the same thing. They said, you are the world's largest global technological institution. Help us procure ethical systems. So that project, in terms of ethics certification program for AI, was born in 2019 or late 2018. I have had the pleasure of being the process architect and being with that project ever since. And the intent was, what do we mean? What are the principal focal points for ethics when we come to actually distinguish and discern and list that we received from those governments in Europe, where we are interested in transparency of AI and explainability. We are interested in fairness and freedom from unacceptable bias. We are interested on measures of responsibility and accountability. And later on, we went about developing those. And later on, we added matters of ethics of privacy rather than legality of privacy. As we know, there are reasonably distinct dimensions. And finally, what is responsible governance of AI for an enterprise? And one observation I would add to all of these, it's really fascinating and hugely encouraging that enterprises have their own versions of codes of ethics and rules and even internal mechanisms for, if you like, oversight and guidance. But ethics, frankly, needs to be verified independently, not claimed by the same entity. And that is a fundamental feature, makes it different. I can't come and say, guys, trust me, I'm a good guy. That needs to be really appreciated by some independent verification and scrutiny. Now, what was interesting, as we were developing, how do we qualify and characterize accountability or transparency or freedom from bias? And we wanted it quickly and not, again, another big list of 20 principles and be good to your neighbors and that kind of generalities. We faced interesting question that a city, a global city, was using AI as part of rolling out services to its citizens, came to IEEE and said, we've heard you guys are developing, if you like, characteristics of these essential qualities. Here is our product. Can you help us make it ethical? They said, we are developing this product in-house in the city of Vienna, and we don't want to face the citizen later to be accused of we ignored or created discrimination against a specific group, or we haven't explained it adequately, or we haven't shown sufficient responsibility or decent responsible governance. So we said, yes, fantastic. Nothing better than proof to show the quality of the pudding. So we accepted their case. It took us 1 year throughout the pandemic and COVID with significant organizational problems to actually take that city through our process of ethics certification criteria. And now we've got 5 classes of ethics certification criteria. And when I'm talking about criteria, I'm talking about 150 SMART criteria. We're not talking about bullet points and checklists and impact assessment or that kind of thing. We have already developed, with the help of very intelligent and very diverse teams of experts, what characterizes accountability, what characterizes ethical privacy, etc. And we actually applied all of this to a real big city who wanted to be progressive and, if you like, advanced and hugely responsible to their citizens. The outcome was a fantastic success, even though it wasn't outright brilliant, if you like. We took them entirely through evaluation through our criteria. And last November, we attended a ceremony in Vienna in the city hall, where we submitted the first global ethics certificate for application of AI in public services to a global city. And they were proud, we were proud that our principles actually worked in practice. And now we have given them what we call ethics progression report. So we said, look, you didn't really pass all the exam questions. You had a profile, you had areas of weakness, you have areas of strengths. These are the areas we expect you to keep on working on. So in terms of your question, where does a standard or any other guideline help you generate and develop a better product or better service? My philosophy about this is that ethics is not a destination. You do not achieve it and get a certificate and hang it from the chief executive's wall that we are ethical. It is a journey. It's a never-ending journey. It's a forever journey. Forever we strive to do better in all these dimensions of transparency and accountability and reduction of bias and better governance, etc. So our approach have evaluated a real AI application in a mega city who strives to be one of the leading global cities, and hats off to them, frankly, for their initiative and care and accountability towards their citizens. And they received their first global certificate. And I see that probably as an exemplar for all other global cities to take the matters of public responsiveness and duty serious.
Alice, thank you so much. Is there, because Vienna is an awesome city, as mentioned, because for years they've been in the top 1, top 2 position as the best city to live in. As a side question, do you think there's a correlation between that desire and this question they ask you?
I think so. They never hit the desire to retain #1 leading, caring, best quality of life city in the world. When we went for a launch of both giving them the certificate and launching the 7,000 standard that I've mentioned, both of those happened in November last year, 2021. They did mention that not only they are proud, they want to bring a lot more of their services for independent scrutiny and certification. They can do it. They said also, please teach us. We want to do this in-house because forever we'll be innovating, either purchasing or innovating AI solutions for our citizens, from health to education, to public services, to utilities. So we want to learn this, but we did mention that for value and, if you like, for credibility, please allow independent scrutiny rather than grant yourself a certificate and say, trust me, I'm a big organization, I'm responsible. I personally, from a personal view, not from the IEEE's perspective, do not believe anyone self-certifying in ethics carries as much value, frankly, as does in safety and sustainability, etc. Frankly, those are very different. But in ethics, it needs to be independently scrutinized and verified.
That's a good remark. And last question on Vienna then. Is there any public knowledge or public information you can share for people who would be interested to read up on what Vienna has done?
I would paste in the chat box a link to the website where we have placed both feedback from the officials of the city and the description of what was analyzed for general access, of course. I'll paste that
Ali,
link.
Thank you. You have to be an engineer because you're so hands-on in this case, so I like that. Now, are there other examples, maybe from the other panel members, where you've seen it made a difference, being aware of do we need ethics? If not, I have another question I'd like to move on, and that's actually how we're going to get the future generation involved. And that's also where I'm going to ask Mr. Gong to also comment on that. Now, very black and white, or very simplistically stated, I want to discuss with you how to engage engineering students in social science. Because, and this is my personal experience, the assumption is that not all engineers are interested in the ethics side. They just want to engage in building something, building a bridge, building a piece of technology. So how can we get those engineers look at this issue, and how can we explain to them why it's important for engineers to understand the ethical principles of AI? Maybe Gonki, maybe I can ask you first reply. And I also want to go back to Claire, see how she does that.
Thank you. Thank you. That's a very good question. I think, in fact, back to 10 or 20 years ago, the engineering ethics education has started in the context of sustainable development, especially environmental protection. At that time, I was working in the university, technical university, for many, many years. And when we introduce these courses and to let the young engineers to be aware of those accidents happened in the real world, that is because of the ignorance in the engineering design, or the ignorance in the engineering maintenance, and so on and so forth, and that harm people and harm the world. And they are very interested to learn how can we fix this problem, how can we have a better design at the beginning. So I think that's a good example to carry out the engineering X education at the beginning in the engineering courses. Now we try to, in my university, we try to turn these kind of education into different engineering disciplines, not only as separate courses as a general engineering courses to every engineering students, but we want to deeply embed these awareness, knowledge, skills into different disciplines. For that purpose, a very important task is to train the trainers. So a training course for the teachers has been developed to let them be aware, because AI is a general technology, will be used in different fields of engineering. So different engineers with different professional knowledge should have the awareness of the problem and have the skills to identify the potential concern and the problem. So we are carry on our works on this and see good feedback so far.
Good. Okay, so you got some people looking up. Claire, how do you raise this question? Why is it important they understand this?
It's important because technology enables all kinds of processes, does not exist in a vacuum, and artificial intelligence, especially in human impactful applications, brings those issues to the fore. So how can we ensure that we do better? Like everywhere, if you start teaching certain skills earlier, then you get more experts, and the experts, as they develop their core expertise, also have more time to develop additional expertise. So starting to teach artificial intelligence in school rather than university, preparing data scientists earlier is certainly not a bad idea. Intel has a set of programs where we work with high school students, community college students to bring artificial intelligence to them. And this includes both the technical and the societal components of the field. This program now operates in 28 countries, and it's going to be expanded. The second option, of course, is to make artificial intelligence as a big picture artificial intelligence engineering plus ethical and societal issues part of the curriculum in universities. If you include as a requirement for graduation classes in social science, then for sure engineering students will have additional knowledge of ethics and how to apply this knowledge. When you build this curriculum, you will also need to have professors who know how to teach engineering while being conscious of the requirements of ethics. This means applying the principles of seeing big picture artificial intelligence to this category as well. Investing in research that is technology research, but also includes as a necessary component a series of ethical requirements. The more research we fund, the more specialists in these areas who teach students we will have. Organizations that deal with artificial intelligence, whether they are deploying it, developing it, or looking into emerging areas of artificial intelligence, all of them will need to develop processes like Intel has done, where ethics is present and reviewed at all steps of the way. It is possible. We already have knowledge how to do this. Similar approaches were taken when privacy became front and center with the advent of the World Wide Web and global data sharing. So we already know to some extent how to do this. And finally, just like we did in privacy, there is need to translate technology operations, techniques and methodologies into principles, or rather link principles with how they could be implemented technically and process-wise. Again, our experience in implementing privacy principles, principles of privacy by design, via translation of these principles to technologies can come very handy here. The European Union has considerable experience in this. Many programs have been funded that focused on this translation, and lessons learned from these programs, from the projects that have already been executed could be very useful in this area as well. Those are just a few things that we can do immediately, but there are more, probably, as you mentioned earlier, a subject to a separate seminar.
Yeah. Okay, great, thank you. I am going to raise a thought I have listening to this, and that thought might be unethical, but I want to take your take on it. Because somebody remarked during the panel discussion that to self-certify something, it may not be the best solution. Now, I want to link that thought to another question I have is, as an engineer, if I build something, the more guidelines I have, the more constraints I might have. So I could be holding back on innovation. So what would be the thought be? Just let the engineer be the engineer, try to innovate and build as best as he or she can, but we will have a separate entity looking at the aspects to govern if it actually fulfills a couple of restrictions we as a society would like. So any thoughts on that? And Toyosi, I see you nodding. Do you have a first thought on that idea of separating the two?
I mean, Frits, I would think that we should stay away from streamlining or stereotyping engineers, boxing them into a corner, because I think in a way it will compromise their creativity if we said engineers build, but make sure that you ensure that there are ethical dimensions to building. I think it's important for us to have separate teams who look at issues around ethical AI and ethics, the application of ethics to engineering products, if you like, you know, separate from the engineers themselves, because engineering is very fluid. These are people building either hardware or software. And in the course of building, engineering is intentionality. So in the course of building products, whatever it is that they're building, if you have to give them, if you have to layer ethics in engineering, I think we would lose the opportunity of having very well-rounded products. I also think it's important to have another set of, set of pairs of eyes that can look at ethical issues, because you see the skill set, the environment, the sort of knowledge that is required for someone to understand governance and ethical issues, data privacy issues and all of that are totally different from the skill sets of engineers. In fact, if you look at a lot of engineering companies, you'd find that in product design, one of the biggest advocacies right now is the importance of teaching soft skills to engineers. A lot of engineers are very bright and brilliant when it comes to the hard job of, concept designing, product prototyping, testing, beta testing, product deployment. But when it comes to the soft skills of empathy, emotional intelligence, inclusivity, you'd find that those things are absent. And that's why there's a huge advocacy around diversity and inclusion when it comes to engineering these days. For example, if you look at the seatbelt of a car, you would clearly know that those products were designed by all male teams. Because if you had more women in the room when such products were designed, they would have factored in, how that seatbelt in its current design state would affect a pregnant woman. You'd see research showing that more women, about 70 or over 70% of women are most likely to sustain serious injuries during accidents than men are likely to sustain, injuries. So I would say that you compartmentalize those sort of that thinking, allow engineers to go with the flow, design products, but around governance, ethics, and privacy are in a different realm. There are legal issues, there are lawyers involved, there are data analysts involved, the data scientists involved, there are compliance and regulatory issues involved in ethical matters. And I don't think that there's a single person that can have all of those varying competencies, all in one, and you still want a really world-class product.
Yeah. So if you want an ethical design or an ethical result, start at the beginning and make certain your team is diverse, because then it's going to be built in ethical.
Correct.
Great. Got that. No, I like that. Now, Gonki, I saw when I made that remark, you smiled a little bit. Did you recognize this? Do you have a different opinion?
Actually, I think at first, we should build the engineer ethics in the mind of all engineers. That's very, very important. Engineers should be aware about his or her responsibility to the environment, to the people. It is very important. It's the first point. The second point is we do need independent organizations, independent teams to test, to review, and to verify the ethical standard. If the ethical standards is really embedded in the technical specifications, it's really implemented in the application systems. So these 2 points complement each other. So that's my point.
Good. Okay. No, thank you. Now, ladies and gentlemen, we're almost at the end of this panel discussion. We have a small 10 minutes left. because I also want to give an opportunity to the organization to provide some closing remarks from their side. Now, we had this debate discussing ethics in AI, why we need it, how we get there, the relevance of standards, and a couple of examples. So I'm very pleased we've been able to share that information with everybody. Before we close this, I would like to ask all panel members, including our, let's say, extended panel members, so including Maksim, if you have a final closing statement, a takeaway for the audience you'd like to share. Is there anybody who would like to start? Ali, yes, thank you.
A quick remark about whether ethics stifles innovation. Frankly, I go along with Gong's perspective that this is a social duty, it's a social development. And I come from the background of complex systems, safety and security design. You cannot slap on safety after you have done all your work and say, here's my product, who can make it safe? I can prove to you scientifically that's virtually impossible. No one would certify your product. You say, leave me alone. I want to be innovative. I'm an engineer. I want a free hand. I'll comply with this and that. When I've finished, I give it to you. You add all the protections that make it safe. Virtually impossible in system safety, in system security, and scientifically, not just based on soft skill and opinions. So that's one point. And I entirely go with the perspective that ethics need to be taught and become an ingredient of mental model for engineers, not that you are free, go and do what you like, we come back and we punish you for your failures. On the perspective of where we go from here, if we take a historic view, it's taken us 2,000 years to get where we are in terms of recorded civilization. In certain cultures, 5,000 years from the Far East. Now, all we have to bless ourselves with is respect for money and property and respect for life. That's all we have. Most of our legal systems, protection systems built in the most advanced societies are evolving and revolving around these principles. We should have been focusing on ethics 1,000 years ago, not today, because AI is coming to take our dummy away. And we are now crying, what happened to our freedoms? Somebody give it back to me. I may be discriminated, etc., etc. So my recommendation is not only this is a social responsibility and significant social responsibility and long overdue transition for the society to say, we have ignored this dimension of respect for other people's cultures, values, and traditions. And it should have been a long time ago that we did this, and it should become part and parcel of our social fabric. I finish with one tagline. My perspective on this as a humanist is that we should make the transition, very bold transition, from shareholder value to social value. If we make that transition, we have won. If we hide behind superfluous statements and flattery and we are good at this and that and leave us alone and we want to make more capital to give to others, we have lost.
Ali, thank you so much. I mean, it's clear to me why you became the chair and technical editor of Standard. So you've proven your point. Thank you. Any other takeaways? Last final comments?
Sure. I would like to say the following in conclusion. As we look at artificial intelligence, we shouldn't lose sight of the big picture. We never should lose sight of the big picture. AI, for all its risks and potential pitfalls, has been extremely beneficial for society. It helps solve many everyday problems, for example, in medicine, and it helped improve processes that we use every day, for instance, in transportation. AI as we know it today, however, is only possible because of the advances in general computational power. It would not have been possible without that, without advances in storage, in networking, in battery technologies, and so on. Machine learning neural networks have been known for decades, but they only have become possible, of course, because the optimization of the algorithms, but mostly because the computing infrastructure, the computing power was finally there. Without this, we wouldn't have been discussing the ethical issues in artificial intelligence that describe the current generation of AI. So we really need to look at the big picture, the technology, the skills of those who build the technology, the ethical and societal issues that we need to resolve in order for this technology to be adopted, all together, not separately.
Okay. Thank you, Claire. Now, would Intel be willing to sponsor those small stickers we can put on everything, like ethics inside?
This is, a question to our marketing department, the head of Intel marketing, but I will ask for you. It's a good question.
Thank you. Great. Okay, Toyosi, any final thoughts from your side?
I just wanted to sort of like say that as we build AI systems, it's important to be very sensitive to diverse backgrounds. And we must not assume that AI methodology have to be universal. What is applicable in America is not the same as what is applicable, in Africa. And at the end of the day, Africa is like the next frontier when it comes to business and opportunities. And a lot of the other continents would benefit a lot from, we're seeing the reskilling and upskilling of young people, especially around Africa, and how, they're taking over the world of, technology. And I just wanted to say that inclusivity is very important when you think about, modern AI systems, and how, corporate environments need to sort of like ensure that in designing, their programs, it's very diverse. It takes into account the values that are important in guiding the projects and the products that are being designed, more than simply deploying the products, for society. I think the underlying values are crucial, and these values will be representative of the interest of the people who come from the varying backgrounds that we put on the table in the course of working on this program.
Yeah. Hey, Toyosi, thank you so much, and making it very clear how important the design of the design is.
Correct.
Yes. Okay, you had.
Okay, thank you. I think I would like to stress the slogan I have seen a few years ago in UNESCO, that is AI with human values for sustainable development. That is what we want. So the problem is how to embed the human values into AI system, into the hardware and software. That is a very important challenge to all engineers. So we have to make efforts to embed these human values as recommended by UNESCO in his recommendation into the AI system. So that's a big job of engineers.
It is, yes. Maksim, it's World Engineer Day. Any last comments from your side to this community of global engineers?
Yes, thank you. I mean, I would say the same thing that I started with when I said that the important point I want to make, in the sense that for you to take away from my presentation is that AI technologies are not value neutral, meaning they are not just tools which people use for good things or for bad things. No, it's it's important to look at the whole life cycle from research, as I was saying, design and development to deployment and use, maintenance, disassembly, termination, etc., etc. So because if we're only looking at the end of the cycle where we are already using them at the time to use them, but it's too late. We need to look into it into all stages, and that's in all stages we need to embed ethics, as Gong was saying, and the recommendation kind of sort of a platform on how to try and do it. Thank you.
Okay. Hey, no, thank you for that feedback. Although we discuss AI and ethics, your comment, we can make it more general. Technology as a whole is not neutral. It has a component, and that's why this discussion on ethics is relevant for an engineer. And I do hope that everybody who attended this, anybody who's going to watch this in the future, the awareness that this is a question people should think for themselves and think for apply for what they're working on. That's the first step, and that's the key. So from my side, I want to close the panel and thank well, the panelists, Ali Hessami, Claire Vishik, Toyosi, Akerele, on your input, and the I would say my sidekicks and fellow panel members, Maksim and Gong for your added contribution. Thank you so much. It's been my honor, and I'm going to hand over to Peng Jing to close off. Thank you.
Frits, thank you so much for chairing the panel discussion. Thank you so much, all panelists. You presented us with such a fantastic panel session. It's very interesting and inspiring. With the time limitation, let me thank all the speakers and the participants. Let's shoulder their responsibility and work together for ethical AI engineering. With that, I would like to close this webinar. Thank you all. Have a nice day. Goodbye.